So today we've got a EOR related type of theme. And as you've seen, so we're talking about whether enhanced oil recovery CO2 storage should continue playing a role in the future deployment of carbon capture and storage technology. So a lot of the major projects for CCS include EOR as part of the business model. And if we're really trying to drive a net zero emission carbon future, should EOR continue to play? Because there's arguments against EOR being something that contributes to global warming, as in it recovers oil, which then gets burned and then emits CO2. And maybe this is not something we want to incorporate into our plan or pathways. So today's topic is on whether CCS EOR should be continued in these projects. Should we be thinking about policies that should we be supporting it with policy or disincentivizing it? And so we've got a group of panel members who will speak on different components or different topics related to this EOR issue. So we've got Benaiah, who will talk about the technical challenges and opportunities of EOR. David will talk about the commercial perspective, whether CCS can actually happen without EOR. And Nixon's going to give his systems perspective on whether EOR has a role in this net zero transition. And Oytun will talk about the EOR policy and public acceptance piece and talk about how policy may support or disincentivize EOR. And they'll give their perspectives on each of these components. First, we'll have Benaiah, who will speak first. And so Benaiah, he is a postdoctoral researcher at the Danish Hydrocarbon Research and Technology Centre at the Technical University of Denmark. He actually did his PhD at Imperial College, and this was focused on chemical reactions that occur after the CO2 has been injected into reservoirs. So he is quite well informed to speak on this technical piece of enhanced oil recovery. So please take it away, Benaiah. Thanks very much.
Hi, thank you, Mai. Yes, my name is Benaiah, and right now I'm based at DHRTC, and it's quite similar to QCCSRC, that's a mouthful, that many of you are already familiar with. And Denmark, for example, decided to end its oil and gas operation by 2050. And it is actually the largest oil producer in the EU, so that makes it very interesting as a context for this conversation. And at the center, we've been thinking about how do we transition from enhanced oil recovery processes to being part of the global or more comprehensive energy transition. Just like Mai said, a lot of the CO2 injection projects are mostly CO2 EOR, where you're getting hydrocarbon out of the ground. And these are usually initiated at the tertiary stage. So there's a primary, secondary, and a tertiary stage where EOR processes are initiated, including CO2 EOR. And how do we go about deciding what to do when it comes to CO2 EOR or any CO2 injection process? Well, we have to think about the capacity, the storage capacity of a reservoir. And overall, saline aquifers, another geological formation, tends to have much more capacity for CO2 storage. In Denmark, for example, it estimated saline aquifers would account for about 95% of the CO2 storage capacity. It's similar in the UK. I think globally it's about 98% of the storage capacity is in saline aquifers. However, saline aquifers are not as properly characterized as hydrocarbon reservoirs because we have a lot more information on those. We have a lot more information on the geological and petrophysical characteristics of hydrocarbon reservoirs. In terms of injecting CO2, you also want to understand the conditions in the reservoir because that affects, so for example, pressure and temperature conditions affect the thermophysical properties of CO2, and that would affect how CO2 mixes with the oil, and whether you have a mixable displacement system or an immixable displacement system. So these are some of the considerations you have to think about. And there are chemical reactions that could occur when you inject CO2 in a reservoir, including precipitation of unwanted precipitation of asphaltenes and also dissolution of minerals such as carbonates, carbonate minerals mostly. And of course, finally, we think about the cost, but I think there's a much more detailed conversation on that coming up. If you go back and think about the history of carbon storage, the main one, the first one being in Norway, Sleipner project in 1996, that has been going on and injecting about 1 million tons of CO2 per annum. And so far, there hasn't been, as far as data suggests, no reports of leaks, and that seems to be going well. But that leads us to ask the question, what initiated this particular project? Other operational concerns for us to think about today is the source of the CO2. This is very important. Most of the CO2 EOR projects right now are actually mostly in the US, and the source of CO2 is from underground reservoirs. So from a net zero point of view, it doesn't really add up to extract CO2 from natural reservoirs and then use it for CO2 EOR projects. Of course, those are accessible, but if we are thinking of this purely from a net zero emission point of view, how do we deal with that? And US, for example, has also a more extensive network of CO2 pipelines. So it's a lot easier to implement in a place like that with existing infrastructure. And when we begin to think about other systems and other setup around the world, what kind of retrofitting do we need to set up? CO2 can be very corrosive. What kind of material compatibility considerations do we have to account for? And are we going to inject in offshore reservoirs or onshore? So these are operational considerations. And if we are to meet all of those considerations, what's the energy balance involved? So are we still net zero if we keep injecting more CO2 in underground reservoirs and having to account for retrofitting, material compatibility, moving things around? What is the life cycle analysis? And if you look in the literature, you get different answers depending on how they draw the boundaries. So are you looking cradle to grave, gate to gate, and all kinds of analysis? So how you draw your boundaries. So these are questions for you to consider. And finally, I'm going to end with this. Right now, like we said, most of the injection process projects are CO2 EOR. But when you have a look at the Global CCS Institute's website, it does seem that from 2021 to 2028, the projects that are expected to come on stream soon are mostly dedicated geological CO2 storage. What has changed? What do we expect to change? Is it a change in policy? Is it a expected change in economics? And are we thinking about CCS more favorably now than we did many years ago? So these are things to consider as we begin to look at CO2 EOR storage more comprehensively from a net zero emissions point of view. I'll end here for now, and then we'll pick it up later.
Thank you, Benaiah. That was a very nice overview of where we are at today from the technical perspective and, the role of EOR now and possibly in the future. So next we're going to have David. And David is a postdoc working on adsorption processes and techno-economic analysis with Camille Petit at the Department of Chemical Engineering at Imperial College. So he's going to give his perspectives on the commercial side of things and whether CCS can actually happen without EOR. So take it away, David. We look forward to hearing your thoughts.
Thank you, Mai, and thanks, Benaiah, as well for your introductory remarks. So I guess I'll start off by saying just in general, I think EOR should be disincentivized. And I think there are kind of two main contributions to that, in my opinion. The first are related to some of the things that Benaiah actually touched upon, which were kind of the LCA related aspects. So right now there's a lot of uncertainty and there are no standards for how those LCAs are or should be carried out. And that gives rise, or basically gives rise to opportunities for a lot of creative accounting, right? And in a situation like we are in now, where we kind of want to ensure net zero or net negative, we can't really we don't want to risk those instances. Linked to that, as is, I think, the case at the Alberta carbon trunk line, both involved parties, so the EOR service provider and the CO2 producer, which in their case I think are fertilizer plants, both individuals or corporations are claiming that they have low carbon products. And in that instance, that is not possible. Right? Only one entity can claim that their product is low carbon. So I think there also needs to be some kind of regulation associated with that. My opinion on that would be that the CO2 producer would be allowed to claim that because their CO2 is being stored. Benaiah also touched on the fact that EOR is not available across the globe or may not be available everywhere. And because of that, I think that presents a disincentive for others to not do CCS, right? With the argument being, if we can't do EOR and obtain some revenue, why should we do it when others can do EOR and gain some benefit from it? So I think they're kind of the LCA style aspects. And the second part is more along the lines of how I think CCS should take place, or if we want it to take place, how it should happen. Unfortunately, many people dislike this view, but I think the only safe approach is regulation, right? So we just impose it, by law. These frameworks already exist in the EPAs and environmental agencies around the world for waste emissions. So that mechanism is already in place in many governments around the world. And considering that this is a very complicated problem, we need to have simple messages and solutions if we want them to be followed and taken place. Obviously, the concern with that is some smaller corporations may not have necessary capital on hand, right, to implement their CO2 capture or removal strategy. And in that case, cheap sources or easy sources of capital are required for those people. And I think that combination is probably what is going to lead to more widespread deployment of CCS. If we want it to be fast, reliable in terms of CO2 accounting, and at the scale we want it to be by 2050. So with that, that's all I have to say, and we'll pass on to, I think, Nixon.
Yes, so now we're going to have Nixon. Nixon Sunny is a final year PhD student at the Department of Chemical Engineering, and he's also a part-time policy advisor for the Department for Business, Energy and Industrial Strategy, or BEIS. And in these roles, he's focused on investigating the role of hydrogen in achieving a net zero carbon future. So take it away, Nixon. Please give your thoughts on the matter.
Thanks, Mai, and thanks to the panelists as well. I think quite a lot of the discussions that have come before has set the scene up quite nicely, and I'll hopefully just add and supplement some of the thoughts. I'll try to keep this brief, but I think it's quite useful to start with a present context, and I think EOR currently still makes up some portion and some single-digit percentage of the US total crude oil production. And in that particular context, it's useful to note there are a couple of points that we should be aware of when thinking about the potential role of EOR and its value in a given system. And when economics is fundamentally going to be one of the main ways in which we drive a system or different suppliers to do something. So I think it's best that we start on that particular point. So in any given EOR system, the oil price and the carbon price that you have in that particular environment will have a significant impact on your economic performance of an EOR pathway. Or if you're an operator, you will undoubtedly invest in the technology when the conditions are particularly favorable. And I think we need to spend some time to think about whether that will be the case moving forward. And in particular, noting that a high oil price and a high carbon price is the best case scenario for an EOR provider, because they're able to maximize the revenue that they've earned through the oil that they've recovered, and they can essentially have a carbon offset cost which falls under the carbon price, so essentially allowing them to operate clean as well. But if we look at how we might transition towards the net zero system in 2050, we may see a lower dependence on oil due to diversification of energy with alternative energy sources coming into play, and that might partially have a knock-on effect on the price of oil, depending on how supply essentially adjust to meet that decline in demand. And then the second case, in order to actually incentivize the uptake of alternative energy sources, nations and governing bodies are likely to use instruments such as a carbon price or another instrument of that, in that sort of order, to essentially allow you to transition different types of industries towards net zero. So the importance with this is that we're essentially transitioning into a system where the oil price may be much lower than we're used to, and the carbon price may be much higher. And there is a question which sort of David touched on very well earlier on, which is that should we look more at EOR, or should we look and focus our efforts on CCS? And I think what I would sort of add here is that when you're presented with this context, what's particularly important to understand is that the EOR system does introduce a lot of uncertainties. And to sort of unpack that a little, some of our work in industrial clusters have essentially shown us that you can have a greater certainty on the costs associated with post-combustion carbon capture or fuel switching with hydrogen, or even the deployment of certain types of negative emissions technologies. But when you try to look at the economic performance of EOR systems, you also have to take into the account of a range of variables, such as how many barrels of oil you can retrieve per ton of carbon you inject, what's the energy content of that oil and its carbon content depending on the composition, and the market price itself depending on how the wider market operates. So this translates into a greater uncertainty for that particular operator. And if we think about the wider net zero perspective, that then has a knock-on effect and translates into a greater uncertainty in the need for carbon offsets. And that's particularly important given that we're having a very active debate about the role of negative emissions technologies moving forward towards 2050. But I guess, practically speaking, there is a question as to who takes the responsibility to offset. Is it the role of the supplier to offset the carbon content of their oil, or is it that of the user? Does the type of end use influence the carbon offset requirements and corresponding costs? Or how do you essentially design policies to ensure that EOR providers are only fairly compensated and not overcompensated, and end users aren't penalized for essentially relying on EOR-based fuels? And finally, how do we monitor the release of CO2 from EOR derived oil? Because studies have shown that EOR oil results in greater carbon intensity than some of conventional oils. So how do we actually, apportion or essentially share the burden of using some of this stuff? And I guess in terms of concluding remarks, overall, the topic of EOR to me results in more questions than it actually answers. And I think that's probably a nice segue into Oytun's section, because many of the questions that you sort of have around the EOR space are to do with the regulation of the design of effective policies and how that could be coordinated at a global scale. So thanks, guys. I'll pass it over to Mai and Oytun.
Thanks, Nixon. That was a really nice, insightful overview on this systems piece and the economics and the challenges involved there. And particularly this issue of uncertainty was being highlighted now by a couple of speakers. So we're going to pass over to Oytun to hopefully give us a bit more certainty around the policy side at least. So Oytun, he's a research fellow at the Grantham Institute for Climate Change and the Environment, and he works on integration issues of energy storage, electric vehicles, and other carbon mitigation technologies into the existing infrastructure. So I think he's going to be well placed to comment on this piece on this public acceptance and policy side. So please take it away, Oytun. Thank you.
Thank you, Mai, and thanks for hosting me as well. I'm an external to the group, but I appreciate the invite to talk here. So yes, my research field is a bit out of the topic, but we have been doing relevant work with carbon mitigation for a while now. And the reason is we look at carbon mitigation technologies and how we can actually develop the infrastructure for it. And that involves public opinion a lot and how people actually interact with. And well, CCS in general, but especially EOR is a bit weird of an infrastructure because you don't necessarily interact with it on a daily basis. So the I guess discussion points on the policy and public together is a bit tough to cover altogether, but I will maybe start with saying a few things about the acceptance because there's a lot of different ways to actually categorize acceptance or try to define it. One is like if we give examples from wind power, you might be well accepting wind power and you might think that okay, it's a good idea to do. That's the acceptability part of it. And then you can go ahead and say, I'm actually okay of having a wind turbine in my community, which actually you step into the acceptance part. But then there is also a different bucket where you actually do something to promote or kind of to stop it from happening. So that's kind of the, I guess, the end interaction of from the public side, I would say. So in connection with EOR, the issue is people, first of all, don't have a lot of ideas about carbon capture and storage technologies in general. It's a fairly new concept to non-expert people. And even for experts, people are trying to grasp the boundaries of it. And EOR is kind of a special case. And I mean, it was a business driver so far, but its also purpose is not always perceived as what the CCS is trying to do. And if EOR is perceived as a mean to maximize the profits from oil recovery, then there's a risk of having backlash or kind of lack of support for other CCS projects, which might be kind of hindering the climate goals in a way. So one issue there is, okay, government wants to make it happen and EOR maybe drove the CCS forward so far. But the problem is at some point they have to make a distinction between these two. And especially in the later years, there has been re-announced goals of having CCS projects more seriously. So this is kind of a chance when the government can actually make a point that storing carbon dioxide as kind of a separate geological infrastructure is different than trying to make the best out of existing fields. And it's not to say that EOR is not useful and public might not see it useful. It's just that the government should lead the discussion and make sure that the EOR is being undertaken in the best of public interests, not in the interest of the companies in a way. And when I say government, it's obviously not just UK, it can be US or European or even China started to talk about these public support and opposition topics more in detail. So a problem is we don't know how to quantify public opinion, right? It's quite tough. You do focus groups, you do face-to-face interviews or questionnaires, but it's quite tough to understand what's happening in that field. But the way that the government can actually change opinion is to give clear incentives, or we were talking about disincentives so far as well, to make a technology happen or avoid from happening. So, for instance, right now, I guess one of the clear financial incentives to EOR is in the US, and it is embedded in the 45Q tax credits, and it kind of defines a price for tons of carbon dioxide that you can sequester away. And when you look at it, the EOR applications are being compensated similar to geological sequestration. And of course, if you do geological sequestration, you need extra infrastructure. It's kind of, you're almost building everything from scratch. So when as a government, you're putting everything in the same pockets, it's kind of signaling that you're valuing them on a similar level. So this kind of is important because if you want to seriously push for CCS projects and want public to kind of accept such investments, you have to also make clear schemes that target a single purpose. And in this case, if CCS is being promoted as a way to remove emissions from the atmosphere, then the government should make it clear that, okay, this is our goal, this is how to make it happen, and we'll provide this incentives for this technology, and we will make everything transparent. So I guess one last thing before I give the platform to the listeners. Trust is the key here, because since the public doesn't have an opinion yet, it can go either way. So you can actually give trust, which is seen as the best way to make people less concerned about the risks of a technology and show the benefits in a more acceptable way. This is kind of the chance that the governments have. So when they give signals, they should, when they, for instance, announce these large investments, large public investments for these technologies, they should first make it clear between each other that, okay, this is where we want to go, and then make it clear to the public that this is what we should do. And there should be transparent discussions before that, so then you don't fall in the danger that the discussion itself will hinder the investments and the technology from moving forwards when you need them. So that would be it for me.
That was a really nice overview on this public acceptance piece, and it sounds to me that you're saying that, you know, it is up to the government to kind of give the clear message and the signals if we're going to kind of move things forward, and this trust piece is being quite important. So I guess we're in this tipping point right now, with particularly in the UK, and kind of keeping the trust of the general public is going to be quite important. And so making sure policies are clear and transparent is going to be a key thing that we should focus on. So now we've got, you know, we've gotten everyone's comments about this issue, and we're going to open the floor to the different audience members. So if you've had questions that you might want to ask, please raise your hand and then just unmute yourself and ask, and you can direct them to a particular panel member, or just ask a general question and then we can kind of direct it to the right person. So I see, Jeff, you've got your hand up first. Would you like to ask your question, please?
Thanks, Mai. First, I'd just like to thank you all for a really excellent summary of the various issues. I think you've opened up the debate very well. And I think clearly there are strong arguments for disincentivizing EOR from what you said. I just want to play devil's advocate for a moment and argue that people who want to use EOR would argue that we'll need to use oil and gas for many decades, not only because we can't meet all the energy demands with low carbon energy or renewable energy, but we need it, of course, for feedstocks for chemicals and materials. And some might argue that EOR is not simply about producing more oil and gas or reducing its costs, that there are the avoided emissions that you get, because if you get more out of your existing reservoirs to meet future demand, that you don't have to drill as many wells, you don't have to exploit more difficult reservoirs. And so, another systems problem is looking at the future requirements of oil and gas to meet the gap between energy supply and also feedstock supply in the transition, say, to bio feedstocks. Where do those avoided emissions come in compared with the other factors that you talked about? Nixon said that maybe your oil that you produce from EOR has higher emissions than new oil from fresh reservoirs. I mean, that depends, of course, very much on the nature of the reservoirs and the oil. So I just wondered, I'm not directing this to anybody in particular, I just wondered where you thought about taking this broader view that since we're going to have to provide a significant amount of oil and gas, that EOR has an environmental as well as an economic consequence for what we do.
That's opening up the can of worms there, Jeff. So I think like this kind of relates to everyone. So I'll invite each panel member to give their sort of quick, sort of brief comments on this question about these avoided emissions, and maybe that it's not just about the oil, but there's also other products that are being produced, and maybe EOR has a place in providing us that crude oil to make these materials. So just keep it kind of brief comment on this. So we'll start with Benaiah because you had spoken first, so please go ahead.
I do agree, Jeff, that oil and gas will probably play an important role for in the next few decades, especially for production of chemicals and stuff. It's a good raw material for many products. But I think from a net emissions point of view, CO2 EOR, in my opinion, is not enough. It's not significant enough to play a major role if we're talking about reducing overall emission. And that's where I'll leave it for now. We can, of course, explore that further. Yeah.
Thanks, David.
Yeah, so kind of along the same lines, I definitely agree that oil is not going anywhere anytime soon in the near future. And I don't have any problem with performing EOR to produce oil as long as it's not attached to any kind of climate change mitigation disguise, right? So whether you're using methane or, like Benaiah suggested, natural sources of CO2 to perform your EOR, go ahead, right? But in terms of mass CO2 emissions mitigation, I don't think it's the way to go.
Nixon?
Yeah, I don't think I'd probably want to add too much to that, because I was just going to say that, the evidence around using EOR derived oil versus going and exploring new wells for the extraction of possibly conventional oil or possibly even unconventional oil, that's still mixed because of the points that you mentioned, Jeff, as to, it partly depends on where you operate, the type of reservoirs, etc. So there's probably value in doing EOR, and deriving the oil by that means, rather than going and drilling a new well somewhere. But we don't know whether that's the case everywhere. So there's probably more work that needs to be done there. But yeah, I would sort of fundamentally agree with both Benaiah and David in that, EOR probably does have a role, but it's not likely to be a very important climate mitigation role.
And Oytun, last one.
Sure. I mean, I agree with all the comments so far. The only thing I can add is, EOR might be useful to have around, especially as said, if it's not disguised under climate change mitigation methods. The danger here is, I guess, if the public money or focus goes to EOR more than CCS, CCS might not get developed further to a point where it's meaningful. So just one example from our expert assessment that we did with the people from this industry in the US, they were very skeptic about the novel utilization options like synthetic fuels or durable carbon, and they were saying basically EOR will be the future of CCS in the US because it's so profitable and the others are so unprofitable. And they were basically saying 90% of the projects will be EOR. And in terms of the scale, they were thinking probably 30 to 35 million tons per year by 2035, which is a very small portion of what US is emitting yearly. So then it means they are basically saying CCS will not play an important role in the carbonization of the US, and US is a major emitter of the world. So then you can see that EOR is not good enough to actually make it happen. So I'm just worried that it will kind of steal the stage from the CCS.
That's a really good point there. Thanks, Oytun. So we have another question from the audience. We've got Martin. You've got your hand up. Would you like to unmute yourself and ask your question, please?
Yes, thank you. And thanks to the panel for all their contributions. And welcome back to Benaiah. Nice to see you online. Yeah, so based around the sort of discussion we've had so far, I guess you could say that EOR coupled with carbon sequestration is preferable to EOR using, naturally produced, additionally produced CO2. So I guess the question is, firstly, would you agree with that? And if you do, how do you think practically one could incentivize in the market that exists today and that's likely to exist in the coming decades? How could we incentivize that to happen? That's the question.
Would you like to comment on that, Benaiah? Do you have any thoughts on that?
I mean, I do agree, as I had mentioned, that probably moving away from getting CO2 from natural sources would be better for net zero emissions. But when it comes to providing incentives, I feel like that's probably the field of someone else. The legal framework, the politics is a little bit.
I'll direct that to Oytun, who might have
Yes.
some thoughts on this.
I mean, just from the tax credit example I gave earlier, I guess, yeah, political framing is quite important. And one thing that US is doing is, okay, they pay people to sequester carbon, and basically they're putting a price on carbon, but just for that application, and they don't do it in general. So I feel like instead of saying this technology will receive this much credit and that technology will receive this much credit, if there was a more acceptable systemic carbon pricing, then the market dynamics could solve the issue by saying, okay, this is more profitable because I'm avoiding so much carbon by doing this. And there's kind of a fair competition because anyone that can avoid carbon from going into the atmosphere or getting out of the atmosphere will get compensated. And then we can see if CCS projects can move forward with or without EOR, and there wouldn't be an issue about choosing a technology before it happens.
Thanks, guys. So I guess, does anyone else want to add to this or no, to that question? Okay. So, I mean, there's some very important issues being raised, and I think this issue of, the LCA being really important, but the thing is, it's kind of a chicken and egg situation in that, like, people won't do projects unless the regulation and policy in place. But then in order to design, informative policy, we need these LCAs done, and people won't do that unless, they are sort of guaranteed in some ways that the project is going to be, useful or profitable. And so, how do we kind of address this? It's going to be quite difficult. There are some projects that exist now, and they've been kind of helpful in providing some data, which, you can kind of delve into to see, but, is there an issue that, these are very specific to those projects? And, do you know can you present some sort of pathway or framework forward? What are the next sort of steps? What should we be doing now in order to kind of help, inform and design more robust and better policy? So I think I'd like everyone to just comment on that for just a brief comment around the table. So we'll start with Benaiah. Do you have anything, ideas on how we might do, what we need to do for the next steps in order to kind of frame this in a more, realistic and reliable way, I guess?
I mean, CO2 injection projects are not uniform across the world. I mean, there are very few countries that are implementing them. And most of the energy growth and energy demand, growth in energy demand are expected in developing countries. And I don't think they're really represented when it comes to CO2 storage and EOR projects. So it might be interesting to think of a framework that would also include that part of the world as well, as we all move together towards net zero emissions. So I think, for the Sleipner project, the first dedicated CO2 storage was in Norway due to a carbon tax that was placed over there. I'm not exactly sure that would apply the same way across the world. So we need to come up with a framework that's more robust than what we currently have. Oh, yeah.
David?
I've been thinking about this since the question, and I have very dispersed thoughts right now. We definitely need better characterization of storage sites around the world, right? We have very few confirmed CO2 non-EOR or non-former fossil fuel well sites characterized. And that kind of really limits the scope of, application. I think that's the first step, because then you will have some idea of what is actually possible in places around the world. If we look at how much CO2 is being emitted, it's more than global steel and cement production combined, right, on an annual basis. And one is valuable product and the other one is a waste product that nobody wants anything to do with. So we possibly need to shift focus from trying to forcefully make it valuable, right? Because I think a lot of the discussion is trying to make it valuable for a given party, right? Which when you have that much waste product, it's not a simple task without reforming the entire market as it exists already, right? So as a first step, definitely need better characterization of storage, which will then lead you to be able to make better decisions about what you want to do, right? And then once you know that, then you can start doing more reliable LCA, because then you know where your sources are, where your sinks are, what's contributing to them. And then potentially move from there. But that's I'll leave it at that.
That was, very nice. So Nixon, next steps.
Thanks. So I guess, my sort of first take would be that we would definitely need to have more evidence on trying to identify the value of reutilizing existing reservoirs to derive more oil using EOR versus going out and exploring new sites. I think that's a really key point to cover, but also in understanding, whether first generation oil or second generation oil behaves differently in terms of its potential impact based on carbon footprint and everything else. I think we need to implement standards of operation, because the argument that we get better at doing EOR and that somehow makes us better at climate mitigation it's something which doesn't necessarily hold now. We've done enough EOR projects to know how to operate these assets, and we've got quite a lot of experience in actual extraction itself to know how to, run these assets, operate them over the life cycle, etc. So doing more projects for learning doesn't necessarily translate into much benefit at this point. So I think when designing policies, we need to be aware that what we want to eventually do is to do those points that Oytun mentioned, which is to, safeguard and show that CCS is a safe operation where we're able to do all of the steps that are involved, but without sort of getting the messages mixed up so as to sort of indicate that all CCS is something to do with oil. But I think in my eyes, what's probably most important is that we have and engage the dialogue with industry on this, because when speaking to industrial stakeholders, you come away with the view that CCU is still incredibly paramount, but in particular with EOR. But when speaking to sort of other stakeholders within government, and as well as more broadly, there is a view that EOR will not shape up to be a major player. And I think there is a disconnect if industry, the guys who are going to go out there and actually build some of these assets themselves, still take that view. There needs to be bridging the gap so as to help us better arrive at a solution which is socially responsible to an extent. And I think that's probably where we should focus our efforts.
So Oytun, your comments on this?
Yeah. So I was actually going to say something along the lines of Nixon, which he already covered. So I will just add to something David said, which is about the waste management issue. I mean, if we see carbon dioxide as a feedstock that is something useful to something else, obviously we want to use it. But if there's no credible use of it because of, I don't know, technology is not ready yet, or it's just too costly, or people don't have a demand for a product that is made by carbon dioxide directly, that is also accessible right now. The other perspective could be, okay, we generate this waste and we have to take care of it. I mean, we're using water every day. It goes through your system in the house. You are happy to receive fresh water, and then you just dump it and someone treats it for you, and we're happy to pay for it. But because carbon dioxide is something not visible in a way, people don't bother cleaning the system in a way. So if the governments kind of start the discussion about these waste management in a way, that could also create this credible project revenues for CCS technologies that they desperately need. Otherwise, I cannot see how other projects than EOR or very specialized cases that produce ethanol or similar products that are highly valuable in certain geographies would happen. You need the products because you sell and earn revenue. Otherwise, it doesn't work. So the government should basically think about this aspect to create this revenue for them.
Yeah. Thanks, guys. I'd like to invite any final questions from the audience. Does anyone want to ask something to any of our panel members? Yes, Jeff?
Could I just ask, the theme was, should we disincentivize it? So if we do choose to disincentivize it and do that rigorously, I just wonder what the panel's thoughts are on the mechanisms to do that. I mean, one blunt way is that 45Q is only available for non-EOR projects. More subtle ways, generally, I think, people will find ways around, unless you actually say that you only get, in a carbon pricing or trading system, you only get credit for the net carbon stored. So therefore, the oil and gas that's released EOR, you own that emission. And I just wondered what your thoughts were, whether much thought has been given into how this would be done.
I'll go backwards this time. So Oytun, would you like to start first?
I mean, I'm not an economist. I'm an engineer at the end, so I don't quite know how the schemes would work, to be honest. But whenever I do these system analysis and try to find ways that such new emerging technologies could actually happen, the clear way is if there was some kind of carbon pricing, then at least from modeling point of view, everything would be very straightforward. So Just believing in that fact, I believe if there was a way to kind of universally apply that to every technology, if you can regulate and if you can monitor and be transparent about it, then that would be the clear way. I'm not sure in policy world step by step is a better choice, because you want to start things off. So it's good to have some, initial policies, tryout, pilots, and everything. But I feel like sometimes you also have to go for a very strong push in policy to make sure something happens. So I feel like the CCS world, but in general, the carbon mitigation world needs that kind of strong signal that carbon dioxide will not be tolerated at some point, and there will be a price for doing it for everyone, not for certain sectors. And that could be kind of a breakthrough, I would say.
Nixon, how's your thoughts on how to disincentivize it?
Yeah, that's a really good question, because I think just along the lines of what Oytun was saying, you need a long-term signal, and something like carbon trading and carbon price will, give you that. But then if our aim is to sort of fast track this and get this moving along, we need to see something else coupled in with that. And if we're looking at it at a regulation front, then it needs to be coordinated, and it's not something that nations can do by themselves because of the risk of carbon leakage. And I think, operating within the national boundaries, what you can do will be to sort of incentivize the uptake of CCS through the reverse of 45Q in some ways, by putting more money on CCS as opposed to EOR. But then there's a question of how, until what degree do you continue supporting these projects? But I think what's most important is this carbon price signal coupled with the monitoring point, because the importance on having an appreciation for the net carbon removed is particularly important when it comes to any kind of mitigation technology. And EOR, if being open to the same sort of environment, should have the monitoring element quite well defined and set in standards, so that we're able to essentially say with reasonable confidence that we're not going to invest in EOR because it's not a viable way forward, as opposed to us prejudicing EOR and disincentivizing it purely because we think that's not the approach to take. So I think the carbon price signal coupled with monitoring and potentially using sort of financial incentives could be a good way to move forward.
Thanks. So we're kind of short on time. Would David or Benaiah, do you have any additional thoughts to add on this disincentivizing piece?
I would simply add that a more clearer system, a bit of transparency would help overall. I think it's important if we have a more or less an agreed way of doing life cycle analysis, so that wherever you are, we understand what the net carbon is for every single system. I think that will make it easier. It's a bit confusing from one system to the other right now.
Yeah. And David?
Yeah, that was the main point. I think if you could make it on the basis of net carbon, that would be the ideal scenario, and it would make most people happy. But I don't think there's enough trust or certainty in achieving that right now.
Great. So that was a really nice overview, guys, of this issue with enhanced oil recovery and whether it has a future. So I think that was some really nice discussion points that all of you have raised. And we know technically, we can do EOR, but there's going to be issues around the accounting of the carbon, and then, some consistency in the LCAs. David mentioned this double accounting. So we're storing the CO2, and both the oil producer is saying that it's low carbon oil, whilst, the emitter is storing the carbon, and they also have a low carbon product. And is that a reasonable way to kind of frame this? And maybe we're double accounting in that way if we do continue doing, this type of advertising of the CCS EOR projects. And I think some issues around trusts and public acceptance. And right now we're kind of at a very crucial step of, how we frame this, how we market CCS and attaching it to EOR has some risk here, and we may end up, showing this other avenue, EOR, being very profitable, which then takes away the attention from CCS. And so maybe this policy framing is going to be really important in choosing the right way to frame it, so that the right technology goes, through to the end and gets deployed for this net zero future. And so, yeah, I guess that's wrapping up everything, and dealing with this uncertainty is, I guess, the next step of this LCA piece and designing policy. So I guess that's it for us today. Thank you for everyone who's attended and your attention. I'll hand it over to Jeff for his final comments and overviews of things. Thanks, Jeff. Thanks, everyone, and thanks to the panel members.
Thanks, Maya. Well, you've summed everything up. I've little to add, but I simply wanted to thank the panel. I think you've shown how these panels should be run in terms of your very succinct comments and then your excellent answers to the questions. I think we've had some good debate there. So before I say what's happening next week, I'd like invite everyone to unmute their mics and to thank you in the usual way. Thanks very much indeed. In fact, next week we have a talk that leads on from this to some extent. John Huang from Ronnie Pinney's group is going to give a talk about enhanced sorption of supercritical CO2 and methane on hydrated pores in clays, which are of course a key component of shales. And this is the underpinning science to enhanced CO2 production of methane from shales and shale gas, which was an element we didn't explore today, but that opens up a whole new can of worms. We'll be talking about some of the technical aspects of that rather than the political ones next week, probably. But come along next Friday and hear what John Huang's got to say. Meanwhile, have a good weekend, everybody, and thanks for attending. And thanks again, guys. That was great.
Thanks, everyone.
Good to see you, Benaiah.
Yeah.
Thank you.
Bye, Benoit.
Thank you very much.
Thank you all.
Thanks.
Bye, I mean.